We now have our sponsor presentation of the day. Huawei are our host sponsor and have made it possible for us to be here today. I'd like to welcome Catling, who is their principal IT and cloud architect, who's going to talk a little bit about Huawei's offering in the IT space.
Okay, thanks, Keith. Good afternoon, everybody. I'm very conscious of two things. There were some words used in the introduction just then which must strike fear into a lot of people's hearts. The word sponsor presentation and a company called Huawei. It's interesting to be here. Thank you for the opportunity to come and talk to you. I'm not going to try and sell to you anything, although hopefully it doesn't come across like that. What I want to do is spend a little bit of time just introducing Huawei, who we are, what we do in this space, because it's a new area for us in terms of what's happening in the futures for virtualization, for integrated systems that support virtualized network components. And we're doing a lot of fundamental research and development in the areas of how do we take the physical components of what we now know as our network and how do we virtualize them? And what are the requirements that that pushes through to the underlying platforms that support that virtualization? Okay, so I will just run through a few slides which sort of give a feel for what Huawei is and where we're coming from. A few key messages. One, we're quite a big company, we're still growing. The important message on there, which may surprise a lot of people, is that actually EMEA is actually one of the biggest regions for Huawei for revenue globally. EMEA and Europe is a very important market for us. Okay? And within that, the enterprise type space outside the pure tier 1 carrier space is a very big growth area for us. We're fairly new in this area, but it's growing rapidly. It's one of the fastest growing bits of the business for us, and it's a very, again, important part of the business for us. We've been working in this space in terms of ICT, in terms of more of the computing side of ICT rather than the telecom side, actually for quite a few years. A lot of people really haven't heard of us, but we've actually been working with servers, storage, virtualization since about 2002. Okay, so we've got quite a long track record in delivering ICT type services which are converged from telco and IT into large carriers. We're now expanding more out into the enterprise and tier 2 level markets for those enterprise products. We've got a lot of resources. It's one of the things that Huawei is sort of fairly famous for. If you've done business with us in the past, and we do have large pools of resources we can pull together. In the areas of ICT, we have 10,000 R&D engineers. They're just focused on looking at new technologies and doing fundamental type research on what the directions are for technology, for networks, for compute, for virtualization, for cloud, for storage, and how we can pull those together. So we have a lot of resources that are working on these problems. Okay? Again, a lot of people tend to think we're new people on the block. We actually do have quite a lot of customers who already use some of our storage products and our IT products. Okay? We also have a fairly broad range of products. Again, a lot of people aren't aware of the sort of scope and scale of the IT type products we can bring to the market. We actually run everything from, we can build full data centers, containerized data centers, power supplies, cooling units, storage, everything running from the smallest storage you can imagine up to some of the largest storage you can imagine. At the moment, all the data out of the Large Hadron Collider in CERN is stored on a big Huawei array, which is scalable to 200 petabytes. Not many people know that. But it was a very innovative R&D project for us with CERN. So we can go from small storage to large storage. We can build all sorts of server cloud-based solutions. We do rack-based servers, small servers, big servers. We also run our own operating system from a cloud perspective, a telco cloud operating system. More of which in a little bit. But it's equivalent of a VMware stack, complete end-to-end, but we call it a carrier class in terms of it's come from a background and we're designed to operate in a large tier 1 telco type of environment with the level of security, accessibility, performance and reliability that tier 1 carrier class requirement demands. Okay? within Huawei, that's the end of the advert, effectively. Thank goodness, I hear you say. Effectively, what Huawei is looking at the moment is we have a product area or an R&D area which we call Softcom, which is a mixture of software and the telecom side of it. It's looking at how we bring together both the software-defined networking and the network function virtualization capabilities together within a network operator environment. Okay? And it's looking at how we take all the traditional areas, you know, the TDM, ADM, SDH, or the access networks. How can we look at virtualizing all those components under what we would traditionally know as network function virtualization and manage and control all through SDN? And I think one of the things that's happened, there's been a lot of news recently over the last year or so around SDN and network function virtualization. What's happened, I see, over the last year has been really a coming together. It's almost a perfect storm of NFV and SDN together, being deployed together as an integrated set of components, is actually adding significant value over the individual components on their own. So operators are starting to see that they can deliver, you know, new functionality quickly, reliably, cheaply, using these new technologies. Okay, so Softcom, it's a Huawei, area for R&D, and it's a series of products that are in there as well. But we look at that as a way of reconstructing the telecom industry moving forward. Okay, in terms of constructing how services are delivered, looking at the network resource pool requirements and how do we restructure those away from a very traditional high function component to commodity products that are driven through software. Okay, operations reconstructing, where we take, you know, the day-to-day operations management and simplify it through common control and management data planes. Okay, for us, what that meant in terms of providing an ecosystem, an environment where we can build virtualized components, we can manage them virtually, meant that we saw we needed a stack of software, which we call a cloud operating system. It's based around existing technologies. We made a decision originally to build our own hypervisor stack, our own virtualization stack. But very quickly, and it was about 18 months ago, we decided to move away from that towards more open source-based products. So now our whole cloud OS stack is based around OpenStack. Okay? And we use that with a number of additional APIs. And what we use it for is to virtualize all the key significant resource pool groups. So we're virtualizing the compute, the storage, and the networking components within that. Okay? Running across what we call DC2, which is multiple redundant data centers, but they're transparent, whereby the cloud OS can actually move and migrate and automatically load balance your virtual NFV appliances across data centers and within data centers, depending on sets of business rules that you set up. Okay, as I mentioned earlier, the FusionSphere, which is our cloud operating system, it is OpenStack-based. We built a few additional Huawei additional components around that, which we believe were necessary to bring it up to a carrier class level of reliability and functionality, but we adopt and we still publish all the standard OpenStack APIs. We contribute that code back into the market and back into OpenStack as well. But we also support within FusionSphere. We recognize we're not an island. We don't exist on our own. So we also integrate with the existing ESXi, the VMware hypervisors, KVM, Zen. If you look at the storage, we actually have our own virtual SAN environment, which I'll talk about a little bit more later on, because it's part of the how do you bring all these resource pools together and deliver the performance requirements of SAN. And we also have the networking, where we fully support open flow, open vSwitch, etc., within the FusionSphere product as such. Okay? But as I say, the important part of it is based around OpenStack. We're big supporters of OpenStack, and we use it a lot. But it's interesting, if I go back to, I think it was Bert in the first presentation this morning, there was a number of questions around what they use for orchestration, etc. We also use Puppet. within Fusion Cloud as our main orchestration tool. We also use a tool called Cobbler, which is bare metal provisioning toolkit in there. So we've integrated those components in. We think, Puppet is a strong tool in that area. It's helped us to build the environment for simple deployment and management, very effectively. One of the key requirements that we got as feedback out of a number of, our customers was, what we need out of a cloud operating system for telcos was actually tools that enabled self-provisioning, self-healing, and self-managing. One of the, mentioned earlier, this large databases loaded up on large storage in CERN. When you get storage at the levels of 20 to 100 petabytes, which is the levels that they were looking at, they said, we're never going to back this up. Solve. It's a problem. How do you solve that? We work with them to solve it. We're never going to do maintenance of it. If a disk fails, we just want to switch it off. We're not even going to bother replacing it. We need it to be self-provisioning so that as soon as we need more capacity, we just plug a black box Lego brick in, and we get more capacity and we get more performance out of it. Okay? So they were key criteria. And we also see that as key criteria within the FusionSphere or the cloud operating system environment. When you look at the scale of some of the NFV environments you can get to as a network operator, you have hundreds and hundreds and thousands of virtual machines running. We're actually running a project at the moment with a customer where we're looking at virtual access routers, okay, and large public organization, thousands of branch offices wanting to replace existing physical routers, which are big, complex, expensive devices, with simple layer 2 $50 switches. Absolutely, totally unmanaged, no intelligence in them at all. Replace it all with virtual access routers providing all the DHCP, quality of service, NAT capability, etc., you'd normally expect in virtual machines. Now, those virtual machines in that environment are typically one core. They've got 128 meg of memory and probably 8 gig of disk. And they're not very big, but on a single blade, you will run about 300 to 400 of those virtual machines. Okay? So this means your cloud operating system has to have the ability to spin up and down and load balance lots and lots of very small virtual machines. And that's one of the key messages we're learning, is that in this NFV environment, a lot of the virtual resources you're playing with can actually end up being quite small. Whereas a lot of the traditional virtualization toolkits, they look at, how do we virtualize Microsoft Exchange or, a CRM application, and how do we consolidate those? They're very valid points, okay? And as a telco, you have to find a way of balancing that with the requirement of NFV, which is to actually spin up, fire, set off and configure lots of very small virtual machines. So you need tools that can actually manage both. Okay? And that was a key requirement that fed into our requirements list for the FusionSphere toolkit. Okay? So FusionSphere, effectively what we saw is we needed a toolkit that could actually support lots and lots of the NFV type applications, but a telco also needs a cloud operating system that can manage the normal telco apps, the BSS, the OSS, etc., and also normal business IT apps from a common platform, same platform, being able to apply all the security requirements, performance requirements, zoning, regioning, and protection required to actually deliver all that across a common platform. Okay. And as mentioned there, one of the big differentiators we saw with a lot of traditional virtualization platforms, or not differentiators, but issues or problems, a lot of traditional virtualization platforms will have compute, it will have switches, it will have a typical SAN sitting out there on a network, on a SAN network. We started to see when you were firing up hundreds and hundreds of small NFV type virtual machines and the performance requirements, we very quickly were overloading the SANs. It's very difficult for the SANs to keep up. And as well, if you look in the general marketplace at the moment for virtualization, a lot of people are actually saying, there could well be a future in server SANs, these sort of vSANs that VMware have just come out with. They've just released one. You've got a number of tools from EMC and the various other people out there that have got these virtual SAN type products. The whole objective of those is to actually try and get a lot of the hot data transparently up close to the hypervisor so they can service the I/O requirements of these small virtual machines very, very quickly. When you're running a large number of virtual machines, there are tens or hundreds of thousands of virtual machines across a traditional SAN, your SAN becomes the bottleneck. It becomes a real problem area for you. So what a lot of people are doing is saying, well, let's try and move the storage, especially for hot data, all the actual data that's running and is active within a virtual machine. Let's get it all up close into the hypervisor. Okay? And that's what we have done as well. We have a virtual storage product that actually runs, in storage blades in the actual main physical compute layer. And one of the key things about that is, with some of the virtual SANs at the moment, what you'll find is that they use SSD type disks in there. We actually found you needed to get guaranteed, reliable, predictable performance. We actually provided the cache layer up in memory. So we use non-volatile DIMM memory up in the servers, up at the highest level, to ensure that the first level cache was running at memory bus speeds, not PCI or SAN disk speeds or ordinary SAS disk speeds. And that's what that box on the left there is sort of indicating towards. We developed a new storage architecture, which was a virtual distributed file system close to the hypervisors, running and cached in real memory rather than on SSDs to help deliver the level of performance that we required from it. I'm going to skip over that one and get over here. Also, one of the other things we saw is within a lot of virtualization products, it's important to get native performance as much as possible up to the virtual machines. So, within Fusion Cloud, a key requirement right from day one of the things that we made sure we could support was full VMDQ queuing on the NICs, and also the ability to support 10 gig E directed out to the actual virtual machine virtual switch ports. It goes back a little bit, this slide, to what I was saying about a key part of how do you deliver an ecosystem, an infrastructure that can actually manage hundreds of thousands of small virtual machines, and needing to get your storage component up as close to the hypervisor as possible. Here's a prediction from a company. We had a company called Wikibon do some research for us amongst a number of different vendors of storage products, but also customers of storage products, as to where they saw in a virtualized environment storage moving in the next few years. And they came up with some interesting feedback and predictions. And that is, if you look at this, you can actually see, in fact, the actual dates aren't very good, but the middle is where we are at the moment. We're about here at the moment, that's 2014, is there's still a high proportion of traditional SANs in the market, but over the next 5 to 6 years, they see a significant drop-off of traditional SANs being used to support virtual environments, and a significant growth in enterprise server SAN class products. So that's the class of products I was just talking about. They're fairly new in the market. Huawei, we actually started delivering some of those 2 years ago. In our first version of our FusionSphere product, we had our distributed server SAN product that was already embedded within that. So in a way, we were sort of ahead of the curve in terms of R&D for that product. Okay? But just, it's an interesting chart, I find, from what's going to happen in storage. I think storage is one of the biggest and most complex areas over the next 2 to 3 years. There's going to be a lot of changes, a lot of new technologies that are going to happen in there. And you might say, well, what's storage got to do with virtualization and with network function virtualization? It comes back to the point I was saying, during the research we've done with some of our customers, and especially in China, where you have large populations of users and customers, you end up having to support large numbers of small virtual machines. And those large numbers of small virtual machines need very quick access to the underlying storage. So that's why the server-side storage is important for the future of a network infrastructure. Okay, there's some technical detail on there on how that works. Now, to support FusionSphere as an operating system, a cloud operating system, we also needed to provide what we thought was a properly converged infrastructure platform. We developed a product that we felt met the requirements of that FusionSphere cloud operating system. It's a product we call FusionCube. It's based on a particular hardware, set of hardware, one of which is outside just on demonstration. But some significant points about it. It's a fully integrated platform in terms of no external networking, no external storage required. Everything is there within the single box, including the ability to deploy high-performance GPUs, SSD, PCIe cards, etc., and other technologies like that within the actual blades and within the actual FusionCube itself. If you go into a lot of traditional data centers that are delivering big cloud deployments at the moment, what you'll see is lots and lots of racks of 1 or 2U servers. That's the normal deployment. One of the reasons that a lot of the bigger data centers haven't deployed blade chassis in the past has actually been because a lot of blade chassis have got a limitation across the mid-plane or the backplane in that the typical bandwidth is 2 to 3 terabytes across the backplane. If you heavily load up a number of blades with a large number of virtual machines doing a lot of network I/O, you can easily exceed the backplane capability. We recognized that in our modeling, say 2 years ago, and when we developed the E9000 FusionCube product, we made sure that the backplane could meet all the requirements that we had on it. That's why the backplane on this product is in there in green, it's 15.6 terabits across the backplane. It's to make sure you don't have to pre-engineer or worry too much about what type of blade you put into which slot, because you can always guarantee that the backplane has got the bandwidth to cater for it. Also, from another key requirement we had was temperature. Almost all of our products in this area for large network operators, they're all telling me anyway, and also how much power does it use? How do we reduce the power on this? How are we going to get our electricity bill down? Well, certainly I know most customers that we're running with on this platform and most of our others run the air conditioning about 5 degrees hotter than with some of our other competitor products. All of our products are engineered to try and deliver the lowest power requirement, but also require the least cooling to actually keep them running. Okay, so just a few final bits is that, so we've got FusionCube, which supports the FusionSphere, which is the operating system which we think is highly optimized and the best fit for the requirement of delivering a high number of virtual network components in NFV, okay? And we bring that down in the FusionCube and the E9000 chassis in a number of separate devices for compute, networks, storage, and also GPUs, PCI SSD for high-speed disk, etc. So it's all within a single platform. You can scale it easily up. Most operators I know say, we want to start really small with just one single little blade in it, please. But we actually want to grow it to a room this size full of equipment, because if we get the customer base, we want to easily be able to grow it. That was the objective. We scale easily and smoothly. We do 224 gigabits between chassis as stacked switches between them to guarantee the performance between the chassis and the racks. So we believe you can start small and easily and smoothly scale it. Again, this sort of helps support the requirement for the virtual access routers, virtual CPE, etc., running in the virtualization environment, easily being able to start small. If you get the customer demand you hope for, you can easily grow it and scale with it. But the whole system end-to-end needs to be architected to support and deliver that easily. Okay, there's a couple of charts there which are just actually going through some of the specific network cards and things that are on there. Again, within it as a platform, we felt that we needed to deliver very high network attachment configurability. So we have cards with up to 32 10 gig E ports on them, or a mixture of 16 10 gig E and 8 fiber channel, or QDR InfiniBand blades that fit in the back. So again, you can easily hot swap them and move them, expand them, or grow the network to meet the requirements. All attached to that 15 terabit backplane and stackable across up to 20 racks. So it's a significant network capability built into it as well. And we think that as a hardware platform is a good direction. It's not really a sales pitch to you. I'm just sort of trying to indicate to you that I think these are some of the key things you need to be looking at as you go forward. If you're looking at network virtualization, function, and SDN, you need a platform that can support the requirement for delivering and spinning up lots of very small NFV components very quickly, very rapidly, supporting them, giving you simple expandability, simple maintenance, and easy and reliable performance across there, while still delivering everything within a single box. I think that makes your life easier, and they're certainly the key components that I'd be looking for if I was looking to build out significant NFV or SDN capability in a network operations environment. Okay, that's really all I had to say just now. Thank you very much for listening. Any questions?
One thing you said about NFV, I think, is the Intel stuff on VMDQ. History suggests the more you buffer, the worse the performance gets. And I think Intel have gone down a crazy path just to put in a huge amount of buffering to ultimately cope with a problem, which is their CPUs can't cope with high packet switching. And I think they're building in, for people are deploying this, they're building in a lot of problems for the future. And I think you should just feed that back. I'll feed that back to Intel because it's not the answer.
Yeah, it's something that we've noticed in some of the modelling that we've done, that we have seen exactly that the buffering, it's not the best approach to fixing that problem. We support it, and we're seeing at the levels of deployment we've seen so far, we haven't run into any real life problems, but I think you're storing up problems for the future. Yeah.
Paul Mansfield, Rimshot. Do you have any kind of eval and loan program? Because, I mean, I think most people here are probably most familiar with HP and Dell.
Yeah.
So, people need a bit of hands-on to get the confidence in the product.
Yes. Yeah. So the question was, do we actually run a loan program? I know that we do have within, typically a lot of these products we resell through a distribution channel, and I know our distributors, who are all the same big name distributors that you work with anyway in these areas, people like MicroP, Utopia, SDG, SEC, etc. We work with those, and I know that our enterprise channel team are building demonstration loan capabilities within that. Yeah. But I mean, it's also, Huawei is always very responsive directly as well. I know if customers have got any particular requirements, we're always very easy and very keen to listen to what those requirements are.
Is that really true? Sorry, I have to chat. So at BT, I'd agree. We're a very, very big customer. I think if I was to randomly pick people who've tried to work with Huawei here, they might say something different. So if you've got a stack of business cards to hand out, there's lots of people that would appreciate it.
Yes. Thanks, Neil.
Okay, I see one more question at the back there. It's okay, he's got microphones. No, stop, Dave.
You were talking about using Cobbler to do bare metal provisioning. Is that really just for the VM host, or can you also support bare metal compute nodes?
We're using a mixture of the Cobbler and the Puppet in terms of the bare metal provisioning. In fact, we're actually working closely with Mirantis on that. We partner with Mirantis around the world in a number of areas and deployments, and we use their fuel component to do a lot of deployments on there. But we've actually taken components, and Mirantis have worked with us on building, let's say, the mixture of the Cobbler for the bare metal and the Puppet for the orchestration. Yeah. And there are areas where it overlaps. Yeah. I would say I do prefer Puppet, working at a Puppet there. Okay. Thanks very much.
Okay, thank you, Malcolm.